Okay, good morning, guys. Today I'm going to try doing something a little bit different for today's lesson. I'm going to try giving actually a little bit of a lecture, sort of like how we would be in class, and give a little bit of review of where we are so far, and then jump forward to what we're going to talk about today and what today's lesson is going to be on, which is the seasons. I'm doing this because for the past couple weeks, as we've talked about rotation and revolution, I've noticed that there's a group of students who seem to be really understanding the material based on their answers on their Google Forms. And then there seems to be another group who is performing less well than I would like to see. And I'm not really sure what the reason is behind it. This whole situation is very unique and different. But nonetheless, I would like to see if maybe giving a little bit of review this way is helpful to us. Okay, so what I'm going to do is I'm going to share my slides with you so that I can talk through them with you during the video. Okay. All right. Okay, so like I said, the last couple of weeks we've talked about rotation and revolution of Earth. These two concepts are entirely different, and it's very important that we understand what the distinction is between the two of them in order for us to understand their effects on our planet. Okay, so let's look at rotation first. Rotation is essentially spinning. Okay, we can think of a lot of things that we see that spin, an ice skater spinning on the ice, a top on our tabletop, or a basketball spinning on the tip of a finger. These would all be examples of rotation. If we look at each of these objects, the ice skater, the top, and the basketball, each of them are spinning vertically around an axis. Okay, an axis is an invisible line that runs through the center of an object around which it spins. Like the ice skater, the top, and the basketball, Earth also rotates or spins around its own axis, its own invisible line that runs through the center of our planet. However, unlike the ice skater, the top, and the basketball, Earth is spinning at a little bit of an angle. Our axis is tilted to the side about 23 degrees, and then we rotate around that axis at that 23-degree angle. The Earth rotates about every 24 hours. So this is the equivalent of a day for us. Rotation is entirely different than revolution. Okay? Revolution is the orbiting of one object around another. So if we look at this image, you can see that Earth, being one object, is revolving around another object, and that object is the sun. Okay? The Earth revolves around the sun every 365.25 days. This is the equivalent of a year. So our yearly calendar has 365 days. Every fourth year, we add those 1/4 years together to add another day to our calendar, and that is what we know as leap year. Okay. Rotation and revolution are connected. Okay, so as the Earth revolves around the sun, the Earth continues to rotate. Okay, so here we have our Earth revolving around our sun, and while it's going around the sun, it is continuing to rotate or to spin. So every 365 rotations or spins will make one complete revolution around the sun. We learned last week that the revolution of the Earth around the sun is connected to the constellations that we can see in the sky. Okay, so as we rotate to nighttime, right, so the stars are out all the time, we're only able to see them during the day because the sun, or sorry, during the night, because during the daytime, the sun will overwhelm the brightness of the stars. So as we rotate around our axis to get to nighttime, the stars will become visible in the sky to us. Where we are in the orbit, or where we are in our revolution around the sun, will determine exactly which stars we see. So we're only able to see Virgo or Leo or Cancer at certain times on our revolution around the sun. Okay, so how is tilt? So I mentioned earlier that tilt is also important, that the Earth rotates on a tilt, okay, a tilt of 23 degrees. Why does that matter? Okay, because it definitely matters to us. So as the Earth revolves around the sun and the Earth is continuing to rotate, while we are rotating, we are staying at the same degree of tilt. So if you look at the sun, at the Earth at this portion of our orbit or our revolution, you can see that we're tilted towards the sun. As we move around our orbit or our revolution, when we get to this side of the sun, we are now tilted away from the sun. Okay, this is a very important concept because the tilting of the Earth either toward the sun, which we have over here, or away from the sun, which we have over here, is what provides our seasons. Okay, so our seasons being summer, winter, fall, and spring. Okay, so the tilting of the Earth either towards the sun or away from the sun is giving us our seasons. Now, it is important to remember that the planet Earth is a very big planet, and which part of the planet we are is actually going to be important as well. So we tend to break up our planet into two hemispheres or two halves. The northern hemisphere is this top portion of the planet. It is the hemisphere that is nearest to the North Pole. And then we have the southern hemisphere down here, and this is the half of the planet that is nearest to the South Pole. California right here, which I've represented with this red dot, means that we are located in the northern hemisphere. Okay, so let's look at a very specific part of our revolution around the sun. Okay, let's start with this one right here. I've drawn a black line to indicate the equator. So right up here, this would be our northern hemisphere, and this would be our southern hemisphere. Okay, so let's zoom in a little bit here. All right, so like I said, we are in the northern hemisphere. At this point on our revolution or our orbit, the northern hemisphere is tilted towards the sun. Okay, this part is closer to the sun than the southern hemisphere. When we are tilted towards the sun in the northern hemisphere, we experience the season of summer. And the reason that is because when we are tilted towards the sun, we are getting a larger percentage of the direct rays of light from the sun on the northern hemisphere than is allocated towards the southern hemisphere. When we get more rays of light, we are going to get longer days and we're going to get warmer weather. Okay, so what we would experience as summer, right? As we move around our revolution, around our orbit to this other side, so let's look at the other side when we reach the complete opposite side of our orbit. We zoom in on this. The northern hemisphere is now tilted away from the sun. And when we are tilted away from the sun, we are now receiving less or a lower percentage of the direct rays of light from the sun. So here we have less, and here the southern hemisphere is getting the majority of the rays of light. When we are tilted away from the sun like this and are receiving less direct rays of light, this means that the northern hemisphere, or us here in California, are experiencing the season of winter. Okay, we are experiencing winter when we are tilted away from the sun. So what about these two in the middle? Okay, these two seasons in the middle that we know as spring and fall. During spring and fall, the sun is tilted neither towards the sun nor away from the sun. And because we are not tilted towards the sun or away from the sun, we are experiencing weather that would fall in between those two seasons of summer and winter. So if you think about spring and fall, we have shorter days than the summer and we have cooler weather. Okay, so likewise, we have longer days than the winter and we have warmer weather than the winter. We experience intermediary weather in those months because we are not tilted towards or away from the sun at those times. Okay, so let's give a brief recap before you move on to looking at the other portion of today's lesson. Okay, rotation or the spinning of the earth is what is causing our night and days. This is a 24-hour rotation. Okay, revolution. Revolution is the movement or the orbiting of the earth around the sun. We revolve around the sun once every 365 days. And lastly, revolution with the tilt of the earth, which is at 23 degrees, is what is providing our seasons. Okay, so one of my concerns is that not everybody is listening actively to the videos that are presented. So to give me an idea of who is listening actively to videos and the whole video, I am going to ask you to give me the secret science word of the day on your Google form. And today's secret science word of the day is apple. So keep that word in your head as you move to do your Google form today. Okay, I'm going to stop sharing my Google slide and I'm going to actually pull up the next thing I'm going to have you do, and I'm just going to present it to you so that you can get an idea of what you're going to do. So today I'm going to ask you to look at an interactive presented by PBS Learning Media. It is, why do we have seasons? Okay, so you will go, I provided this link for you. Go ahead and launch it. Your screen will look like this. What I want you to do with this interactive is I want you to play around with it so that you can get a good idea of the Earth's orbit or revolution around the sun's path in the sky, which is indicated down here, and the sun's angle in the sky during different points on our orbital path. Okay, they provide you with 4 cities to investigate. New York is going to be very similar to California. New York is located at 41 degrees north, which means 41 degrees north of the equator. San Francisco, the Bay Area, is at about 38. So we are similar to New York. So if you want to get an idea of what we have in terms of our orbit and sun angle and sun path in the sky, New York is a good comparison. Singapore is an equatorial city, meaning it lies almost directly along the equator. So I want you to flip through and look at Singapore. What is the difference in the sun's path and angle for a country that lies upon the equator? And lastly, Melbourne, Australia is a southern hemisphere city. So go ahead, you can click on that and compare what we see in New York or San Francisco at certain times of the year with what you would see in Melbourne, Australia at the same time. This is a good comparison between the northern hemisphere and the southern hemisphere. So I want you to go ahead and play around with this interactive. There are questions on the Google form that it will be helpful for you to have played with this to get a good understanding, a good grasp of the effects of the Earth's orbit on our sun path and our day length. Okay, so after you do that, you can go ahead and finish up with the final 2 videos, which are a brain pop video and a very funny video on Uranus's tilt. So I think that it's cute. And then go ahead and end by finishing up the Google form, and don't forget to push submit on that. Okay, go ahead and email me if you have any questions, and good luck today.